Mechanism of H plus secretion in the PCT, TAL, and early DT. H plus secretion in the proximal convoluted tube, thick ascending limb, and early distal convoluted tube is by secondary active countertransport. Activity of the sodium-potassium ATPase on the basolateral membrane creates an electrochemical gradient for sodium. This enables sodium to move along its electrochemical gradient across the luminal membrane in exchange for H+ via the sodium H+ exchanger. Proximal convoluted tube cells are very rich in carbonic anhydrase. Carbonic anhydrase catalyzes the reaction between carbon dioxide and water to form carbonic acid. Carbonic acid splits to form H+ and bicarbonate. The H+ is then secreted into the lumen by a secondary active countertransport, sodium H+ countertransport or NaH exchanger, primarily NHE3, and the bicarbonate that is formed diffuses into the interstitial fluid. The H+ secreted in the proximal convoluted tube combines with the filtered bicarbonate to form carbonic acid. Carbonic acid splits to form carbon dioxide and water. Carbon dioxide diffuses through the apical membrane of the tubular epithelial cells lining the proximal convoluted tube and enters into the cells. Thus, for every H+ secreted in the proximal convoluted tube, one bicarbonate is reabsorbed. About 80 to 90% of the total H+ secretion and bicarbonate reabsorption occurs in the proximal convoluted tube, but this does not change the pH of the tubular fluid because the H+ secreted is buffered by the bicarbonate present in the lumen of the proximal convoluted tube.